Today we are going to be working on the social distance problem. Now, if you don't know, the social distance problem is a problem with a number of seats, and basically what happens is you are given a number of seats in a row. The program prompts the user to ask which seats are occupied versus unoccupied, and then it tells the person where the next occupied seat should be. And the rule is that the next seat to occupy should be the one that is furthest away from occupied seats, but also closest to unoccupied seats. So you want to be closer to the seats that have no one in them, furthest away from the seats that have people in them. And in the case of a tie, if there's two equally viable seats, then you sit in the one that's closest to an edge. All right. So the way we do this is, let's say, for instance, the user gets prompted and they're going to say like 1 1 0 0 1 or something like that. Okay, so that could be like the ones are occupied and the zeros are unoccupied. All right, so we're going to take those away. I'm going to show you guys how I would approach this. Okay, so what we're going to do is we are going to make a parallel array. So another array that just works parallel with this one. And this one I'm going to call it points. So remember here that our size, well, technically it can go all the way to whatever size you want, right? We're going to say the max size is 5 in this case, but it can technically be whatever. Let's say this is occupied. Well, what does that do to the points? Okay, so what happens is it assigns points into the points array like this. So it gets 5, 4, 3, 2, and 1. And let's say, for instance, the next seat is also occupied. Okay, so then what it does is doesn't do anything to the points in its own cell. Okay, but then what it does, or in its own element, but in this one it says 5, 5, 4, 3, and 2. Okay, so what it does is it starts by assigning 5, 4, 3, 2, 1 as far as it can go to the right and then also to the left. Okay, let's say the next one is unoccupied. Okay, well, what do we do with that? Well, the cells don't do anything to their own parallel cells here, or their own parallel element. But what it does here, because it's unoccupied, it doesn't assign positive numbers, it assigns negative numbers. Okay, and that's basically giving an award for being closer to this cell because it's empty. Okay, I keep calling them cells, but okay, here we have a 0. Let's say it's another unoccupied. In this case, we get a -5, a -4. This would be -5, -4, and -3. Let's say, for instance, this one is also unoccupied. Okay, so this would be -5, -5, -4, -3, -2. Okay, and this is, let's say finally this one is also unoccupied. And let's just see what happens. We'll change this last one in a minute here. -2 and -1. Okay, so what's going to happen here is we can actually sum up all of these cells here and see what happens to the sums of all the cells. Okay, so let's just say is equal to the sum of C5 to C10. Okay, so this element has a total of -5. Okay, in fact, we can just actually move that. We'll put it there. All right, and then this one, we can just move it across, and you can see their sums there. Let's give it back its color. All right. Now, what we're going to do is we're going to look for the nodes or the elements that have the lowest values, okay, that are unoccupied. So these ones are fairly low, but because they're occupied, we cannot sit in them, so they're not in consideration. These ones are -3, -7. They're low, so meaning they're desirable, but we don't want to sit in them because they are not the lowest. And then, so the lowest seats are these two here. And what the program has determined is that these are both equally viable, right? They're both, they're so far away from all these other ones that they're both equally desirable. But the rule is, if you have a tie, it always chooses the one that's closest to an edge. Right, so what it's going to do is it's going to choose this one here. okay, minus 9. Okay, so let's see, how do things change though if this element became occupied? Well, if this element became occupied, then this would not be a minus 5, it would be a positive 5. Okay, and that would be a 4, a 3, a 2, and a 1 like this. Okay, and you can see now these numbers have negative values, and part of this is because they don't assign values to themselves. Okay, so this one see, like it's empty here, it doesn't give a value to itself. All right, but it doesn't matter that they're negative because we don't consider them anyways because they're occupied. So what we're going to do is we're going to look at the cells that are unoccupied, and we're going to say, well, okay, this one, these two have the same points value, but again, we're going to pick the one that's closest to the edge, so we're going to pick this one. Now, it might seem kind of counterintuitive because a lot of people would say, well, we should pick this one, right? But if you think about it, what happens is with this one, you have to sit pretty close to this person and this person, right? So if I sit here, I have to sit close to this person and this person. But if I sit here, yes, I have to sit closer to this person, but I don't have to sit as close to this person, right? And the algorithm actually determined that both seats are equally likely. Like, yes, this one I'm in the middle, but I'm still close to these two people. This one, yeah, I'm sitting beside someone, but I'm further away from these two. So, it's you're kind of equally good, I guess. And basically the rule is then that you want to choose the one closest to the edge, and so this is the one that we're going to sit at, the one closest to the edge. Right? If you wanted to, I guess you could change it to say like if there's a seat available that's not closest to anyone, then like that's not adjacent to anyone, then that would be the most desirable one. But it doesn't actually really matter. Right? But essentially this is how we do it, by each cell or each element assigning a point value based on its value to this parallel array, right? And you can see like what would happen here in different cases here. So let's say this was unoccupied. Okay, so what we would do is we go down and this one would become minus 5. This would be minus 5, minus 4, minus 3, minus 2, like that. All right, and you can see now that here, these two seats are the most desirable at minus 7. And again, you're going to pick the one closest to an edge. So yes, you're going to sit in this one, right? It actually wouldn't really matter, I guess, because it doesn't matter which side you're sitting on. But this one is technically closest to an edge. Well, I guess they're both the same. So yeah, it doesn't really matter, right? So we would probably detect this one sitting closest to the edge first because we look in probably left or right. But yeah, that would make sense. Now, what if we did something like this? So you occupied this seat here. Okay, so we go on. Okay, and this would get a 5, 4, 5, 4, 3, like that. And you can see now this seat here now becomes very undesirable. Okay, because it has a plus 5 point value. These seats are the most desirable at 3 and 3. And again, we're going to pick the one closest to the edge. So it's going to be this seat, right? And so you can see overall, this is a fairly good strategy for determining which seat you should occupy, based on whether or not, you want to be as far away from the most people as you can be. All right. So anyways, what we're going to do now is we're going to go and take a look at how you actually code this. And it's actually not really that hard. To solve the social distance problem, we're going to need a couple of things. And the first thing we're going to need is to take in some input to tell us how many seats there are. All right, so we're just going to ask the user, say, we'll call this number of seats. So number of seats is going to be our total number of seats, and we can just say it's equal to input dot next int. Now, we should put a prompt there, otherwise the user won't really understand what we're waiting for. So we'll just say system.println, how many seats are there? All right, so then we'll say int number of seats, and in that way we'll know how many seats there are. The next thing we're going to need to do is we are going to need to create two arrays. So I'm going to create one array called seats, And that's going to represent whether each seat is occupied or not occupied. We're also going to need another array to represent the point value of each seat. So I'm going to call that one points. And it's going to be the same size as the seats array. And of course, because the two work side by side with each other. So, okay, next thing we're going to need to do is we're going to have to just populate the grid. Right, so we're going to, not the grid, but the line to say which seats are occupied and which ones are not. So we're just going to use a simple for loop for this. So x is equal to 0, x is less than the number of seats, x plus plus. All right, and then we're just going to ask the user and say system.println is seat occupied. And we will give them a prompt saying 1 is equal to occupied, and 2 or 0 is equal to empty. All right, and we'll just make this look a little more consistent. There we go. And we can say that seats at x is equal to input.nextInt. Now, I'm not going to put an error trap here just because I'm going to assume that the user will not enter like faulty data. But, depending on your problem, the requirements of your problem, then you might want to. I'm just not going to bother because it's not really relevant to what we're doing here. Now, to make the math a little bit easier, I'm going to introduce something called a multiplier. So I will say int multiplier just starts off at 1. And you'll see what that's for. Basically, what it's going to be for is to indicate whether or not I should add the number to the points array or if I should subtract it. So I'm going to say if seats at x is equal to 1, meaning that the seat is occupied, then the multiplier is equal to 1. And then if it's not, that means that seats has to be unoccupied. So then the multiplier will be equal to -1. So it means we're going to subtract. Now, I'm also going to need another variable called max points. And max points will be equal to the number of seats. And the reason why I can't just use number of seats is because I'm going to be changing the number of points. Max points is going to be indicating how many points the seat adjacent to the one we are currently populating is going to get. So if we are on seat 5 out of 6, then the seat adjacent to it will get 6 points. But I don't want to change the number of seats, so this is why I'm making basically a copy to work with. All right, so what I will say here then is that max points is equal to the number of seats. I need to put this here because it will change, and then every time I loop, I need to reset it. Okay, and then what I'm going to do is I'm going to say for int y is equal to x plus 1. Now what that's going to do is it's going to go to the seat that's adjacent to the one that we're currently looking at on the right, so the next highest one. And we're going to make it go all the way to the end. So y less than number of seats, and y plus plus. And then for each one of those, we're going to say points at y is equal to, or plus equals to, maximum points. So what we want to do is we want to say, okay, we're going to add the maximum number of points to the one adjacent to it, and we're going to do that for each one after that. But what we'll have to do is that the max points will have to go down. So we will say max points minus minus. Now, I could technically do this in 2 lines. I think it's just nicer in one line. Okay, but sometimes we add it and sometimes we subtract it. So what we're going to do is we're going to say times the multiplier. Right, so if the seat is unoccupied, so it's empty, then the multiplier will become -1. So this multiplier is -1, which means our max points will be negative, and then when we add it on, it will end up being subtracted from the value. If the seat is occupied, then the multiplier will just be 1, and then we'll just be adding itself, and it'll still be the same thing. And no matter what happens, we still want to decrease the max points. So the first seat gets 6, and then the next will get like 5, and the next one will get 4, and so on and so forth. Okay, that's going from the current seat that we're looking at forward, but we also have to give points to the ones beside it on the left, like going smaller. So what we're going to do is we're going to reset max points to be the number of seats. And we're going to say in this case that y is equal to x minus 1. Y is greater than, now we don't want it to go out of bounds on that side. So we're going to say greater than or equal to 0. And because we want this to work for 0, but we don't want it to go below 0. Right? And I believe, yeah, it's the same thing. So yeah, same equation, just going the other direction. All right, now at this point, I think we're at a point where we can test our code. So what I'm going to do is I'm just going to say for int y is equal to 0, y is less than the number of seats, y plus plus, and we're just going to system out print the points for each seat. So points at y plus space, and then at the end we'll just put an end line there. And this way we can see, like, does it make sense? Now in our example, we gave 1 1 0 0 0 1, right? So for a size 6. So let's take a look. So there's 6 seats, 1 1. Oh, let's see what happened here. Okay, so it's pointing me to line 33 here, and yeah, okay, so because I basically copied this, this should be a y minus minus. There we go. All right, so let's try that again. So 6, 1 1 0 0 0 1, and you can see the points values are being assigned every single time here. So let's see. The seat 1 is occupied, or seat in position 0 is occupied, but you can see it's assigned 0.65432 all the way to the end. This isn't exactly how I wrote it in the diagram, but it doesn't actually matter. As long as, like, in the diagram I had in the pre-planning stage, I actually assigned this to be 54321 instead of 65432. But as long as you're consistent, it actually doesn't make any difference. So then seat 1 is occupied. So now this seat doesn't give anything to itself, but it assigns +6 to this one, +5, +4, +3, and then on this side it gives it a 6, and that looks correct. All right, so the next one is unoccupied. So now that's this one we're going to look at. It subtracts 6 from here, which is correct. Subtracts 5 from here, subtract 6, subtract 5, subtract 4, right? And so yeah, it's looking actually pretty good. This one is unoccupied, so this is -6, -5, -4. Yeah, so I believe this is actually working. It actually looks correct. So the next thing we're going to have to do is find the seat with the lowest points closest to the edge. Now, this is actually a little more complicated than a lot of people might think, because a lot of times what will happen is a seat might have the lowest points, but it's occupied. So we have to actually ignore occupied seats. And then while we're searching for the lowest points value, we also have to consider how close the item is to the edge. Because in the case of a tie for lowest points, an item on the edge will actually, or closer to the edge, will take precedent over an item more towards the center. So we're going to need to start this off by just locating the first unoccupied seat. So let's start making some variables then. Just going to make some room here so I'm not coding right at the bottom of the page. All right, so we're just going to say int first unoccupied seat is equal to, and we're going to assume that it's in position -1. Now, the reason why is because when we do a search, we're going to actually look for an unoccupied seat, but if we can't find one, then this index will still be -1, and then we can know that it doesn't exist in the list. So we can use a for loop to traverse the list. So int x equals 0, x is less than the number of seats, x plus plus, and we are going to say if seats at x is equal to 0, that means that we found an unoccupied seat. Then we can say the first unoccupied seat is at x, and we can stop looking because that's all we're looking for. Okay, now we can say also that if the first unoccupied seat now is equal to -1, meaning that we did not find one, then we can just tell the user that there are no empty seats, right? Because if we couldn't find an unoccupied one, then they're all occupied. All right, otherwise, now what we have to do is we're going to go look and compare this seat with every other seat in the list. So what we're going to do is we're going to say the int lowest index is equal to the first unoccupied seat. Okay, also the lowest points is equal to the seat or points at the now would be at the lowest index. Okay, so we have the lowest index is the first unoccupied seat, and then that means that the lowest points currently is the number of points at the lowest index. Now we also need to calculate the current distance to edge. So we're going to say int distance to edge, okay, is equal to the lowest index. Now this is only going to be true if the lowest index, the first unoccupied seat, is on the first half of the array. But if it's on the second half of the array, then it's not going to be true because it will be closer to the other edge. So we're going to say if the lowest index is greater than the number of seats divided by 2, so it's more than halfway through the list, then the distance to the edge is now equal to the number of seats. So we're going to take the size of the array minus 1 minus the lowest index. Now, a lot of people might be confused as to why we need this -1 here. So consider then that if we had 10 seats, so the number of seats would be 10, and we're talking about index 7. So then what would happen is if we just said number of seats minus lowest index, it would say 10 minus 7, and it would say the distance to the edge is now 3. But actually, I guess it might be more apparent if you say 9. Like, let's consider seat 9. So number of seats is 10, right? Then if you're considering index 9, it should be right on the edge. The distance should be 0, right? So, but if you say 9 minus or 10 minus 9, it's going to be 1, and then it'll say that distance to edge is 1, but it's actually 0. That's why we have to subtract 1 from it. All right. Now, once we've determined where the first unoccupied seat is, we now set things up for comparison, and we know where how far away it is from the edge. Okay, so then what we can do is we can start looking at other indexes. So we're going to say for int x is equal to the lowest index plus 1, meaning we are going to start at the lowest index and move forward from there, because there's no sense in looking for things that are not at the lowest index. X is less than the number of seats, and then x plus plus, so we're just going to go one at a time. Okay, then we will ask a question. Now we're going to say if the seats at x is equal to 0. Okay, so that means that the seat is unoccupied. And the points at x is less than or equal to the points at the lowest index. Now this is going to be a little bit problematic. Not really a problem, but something we need to consider, because what we're looking for is that the seat is unoccupied, but the number of points at that seat is actually smaller or the same. And so we have to handle it if it's smaller, and we also have to handle it if it's the same. right? So, okay, so it's less than or equal to the points at the lowest index. What we can say is we got to calculate the distance. So we actually need to calculate the distance to see if it's actually, if we should consider it if it's equal to. So distance equal to x. We're going to say if x is greater than number of seats minus 1 minus x, and you can see that this is actually just the same equation right here, right? We're calculating distance to edge here. Okay, then we are going to say that the distance is equal to number of seats minus 1 minus x. All right, now what we can then say is that if the distance is less than the distance to the edge, so this might be a little bit confusing, but the distance is referring to the current cell or the current item that we're looking at. The distance to the edge is the distance to the edge of the lowest one that we have marked. Okay, so here we have if the distance to the edge is less than the distance or the points at x is less than the points at the lowest index. So we can say, look, if they, so one of two things can happen here is that it's the same, it's going to be less points or equal points. And so this part here is to handle, well, what if it's fewer points, right? The other one is it's equal, and that's what we'll handle here. So either way, we need a replacement effect here. So what we're going to do is we are going to say that we are going to need to start replacing things here. So we're going to say the lowest index is equal to x. Okay, the new distance to edge is equal to the distance of the current node that we're, or the current index we're looking at, and the lowest points is equal to the points at x. Okay, now I just have got distracted here because I have a little red line there. Now at this point, we should be able to go through everything. Let's just make sure everything's cleaned up here. This is clear, this is closed, this is closed, this is closed. Good. So then what we should be able to do now is just say at the end, system.println, the best seat to take is seat, and then the lowest index. All right, so when we test this, if we use the exact same test case as we had before, what we should end up with is a point system like this: -4, -6, 4, 2, 2, -10. The one that we're looking for with the lowest index is a tie between these two, but it should actually say in position 4 because this is 0, 1, 2, 3, 4. And even though position 4 has the same number of points as position 3, and position 3 would have been found first, position 4 is closer to an edge. So let's go and hopefully we get it. Okay, so we have 6 seats, 1, 1, 0, 0, 0, 1. And there you go. Best seat to take is seat 4. Now, just to finish things off, we can take away this test code here. I'm just going to mark this down as being test code. All right, and comment it out. And that's basically the solution for the social distance problem. So in any case, if there are any questions, please remember to put them into the comments. Don't forget to like and subscribe. Thanks for watching, and I'll see you next video.